Right, good morning, boys and girls. Good morning, colleagues. My name is Mr. Mpahama. You are welcome to this session. Today we are going to look at a graph of a cubic function. Of course, you agree with me that there is a lot of marks on this topic, especially calculus, that you must make sure that you collect. Right, let us start now because we don't have enough time today, only 1 hour 30 minutes. Looking at these functions here. Remember now, for all functions, it's very important that you know how to sketch, how to determine the equation, as well as the interpretations. Those are very, very important. Right. Let us now start now with the graph of a cubic functions. Let us see now, what is it that is important here? First of all, now you look at this one now, we have the standard form. We have the standard form. Of course, the standard form of a cubic function is f at x is equals to ax to the power of 3 plus bx squared plus cx plus d. Of course, that is the standard form. And then now these are the shapes of the graph. If a is greater than 0, then if the value of a there is positive, now the shape of the graph now will look like this one here. It means the graph will increase first. You can see here now, the graph increase. We have the turning points, and now the first turning points that will come across there will be the maximum turning points, and thereafter the graph decrease and increase after. And then immediately when it increases, now we are going to have the minimum turning points. That's only when a is greater than 0. Of course, also you'll find that sometimes a is less than 0. If a is less than 0, then the graph, look at the graph, it decreases first. Now, if the graph decreases and then increase, of course, the first turning point will be what? Will be the minimum turning point. Of course, thereafter, now you are going to have the maximum turning points. Of course, the shape, you need to remember the shape. If a is greater than 0, what's going to happen? The function increase and decrease. The first turning point will be the maximum. Then if a is less than 0, the function decrease first. Thereafter, now we have the minimum turning point. Right, this is the shape of the cubic function, of course. Now let us look at the procedure for sketching the graph of a cubic function, which is very, very important, boys and girls. Of course, the first thing that you know, for all functions, x and the y-intercept are very, very important. But what's important is, what is it that you must do when you find the y-intercept? Of course, you let x to be 0. X must be 0 when you determine the y-intercept. And of course, for x-intercept here as well, you must also let y to be 0. F at x, g at x, h at x must be 0. That is number 2. And of course, now this one is very important. Now remember here now we'll be dealing now with what? With the cubic function now. Of course, first of all, when you solve for x, when you find the x-intercept here, what you must do first is you must find the factor of f at x. You must find the factor of f at x, of course, by finding the common factor. Always remember we say the same thing with the quadratic equation, finding the common factor first, or if possible, by grouping the terms together. There are 4 terms. Now on those two, if you group them together, now sometimes you are able to take out a common factor, right? Of course, now, if that one doesn't work, of course, you'll have to use a factor theorem. You remember the factor theorem? Yes, you must find that value that when you substitute it in the original equation there, it must give you what? It must give you a 0. Then we'll see that now is our x plus 1 or x minus 2 is our factor. That is a factor theorem. Right, thereafter, now number 3 there, we need to have what? The turning points. Boys and girls, this part here is very, very important. Very, very important. How do we determine the turning points of a cubic functions? Don't say x is equals to minus b over 2a. That one is for what? That one is for a quadratic functions. That one is a quadratic function. Okay, here what you must do first, you find the derivative. You find f prime of x, and then you let f prime of x to be 0. It means when you're finding the turning points of the cubic function, of course, you need to have the derivative, f prime of x, then you let f prime of x to be what? You let f prime of x to be 0, and now you solve for x. Right, we are still busy finding the turning points here. Of course, now, once you have solved for x, now it means now the values of x that you obtained there, you will substitute those x values into the original equations to find the y coordinate of the turning point. It means from this one here, we will have the x coordinate of the turning point. Now, once you have the x coordinate of the turning point, you substitute x now in the original equation to find the corresponding y value. Right. Of course, boys and girls, now from these two, now you will have the coordinates of the turning points. Of course, we can state the nature of the turning points. Is it the maximum turning points? Is it the minimum turning points? Well, remember now, if A is positive, now you will see which one will represent the maximum and which one will represent the minimum. The same apply if A is less than 0, then you also see, because the function will start decreasing and increase, this side the function will increase and decrease. Okay, right from here now you can now be able to do what? You can now be able to draw now a smooth, curve. Of course, this is what you need when you sketch what? When you sketch a cubic function. So of course, boys and girls, I think before we find the equation now, I want us to look at this one where we sketch the cubic functions. Right. Now, how to find a point of inflection, of course, it's also very important here. You find what? You find the second derivative, second prime x. Can you see that one? You find second prime x, and now you equate it to 0. Thereafter, then you solve for x. You find the second derivative, you equate the second derivative to be 0, and then you solve for x. Good. Now, the next one also, you can also use x is equals to minus b over 2a. Remember now, this one, it means now you'll only going to apply this one in our first derivative. Second derivative, remember now we will be having from the standard form here. When I find the derivative, remember now it will be f prime of x is equals to what? 3ax squared plus 2bx plus c. Then it means this formula here, the one of x is equals to minus b over 2a, we are going to use it in our derivative, 3ax squared plus 2bx plus c. Then it means once you have the first derivative, once you have the x coordinates of the turning points, now you can use the derivative now to solve for x value of the point of the inflection. That is why we say use y is equals to f prime of x. Right. Now, sometimes you can also take the x coordinate of the turning point. You can also take the x coordinate of the turning point or the x-intercept of the parabola, right? Now you just add the 2, you divide it with 2. Then you'll get the x coordinate of the point of the inflection. Of course, thereafter, now what is it that you're going to do? Then you substitute the x value into the original to find the y value. Right, boys and girls, now let us now look at the first part now where we do what? Where we sketch this one. Of course, I'm going to take one of the past paper. Then we solve to see now, we try to apply whatever that I said earlier on with regard to the procedures for sketching the graph of the cubic function. Of course, let us look at this one together here. It says now question 1, that is November 2009. We are given that f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. That is f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. Of course, boys and girls, the first question there, they are saying we must calculate the x-intercept of the graph of f. We must calculate the x-intercept of the graph of f. Boys and girls, now I told you here, what is it that you must do when you do what? When you determine the y-intercept. Remember we said for you to find the x-intercept, of course you let f prime of x to be 0. Now you find the factors of f by finding the common factor first. If there's no common factor, you try first by grouping. And then if it doesn't work, then you use what? You use the factor theorem. Of course, it's a 5 marks question. Boys and girls, can I start first saying that, can you work on this problem so that at least I just see if you understand the procedures for sketching the graph of the cubic functions for about 4 minutes. Then immediately after this one, then we can do it together. Thank you, boys and girls. Let us see now what is it that we must do. What is the first thing that we must do here, boys and girls? Of course, we said when you find the x-intercept, we must let f at x to be what? Must let f at x to be 0. Then it means we have 0 here is equals to minus x to the power of 3 plus x squared plus 8x minus 12, right? F at x is 0. Now, of course, now, boys and girls, I can also make the a to be positive here. Remember, now we are having the equation. We are having the equation. I can divide each and every term here by what? By -1. The reason being, I want to make the coefficient of a there to be what? The coefficient of x to the power of 3 to be positive. Therefore, now we have 0 is equals to negative divided by negative is a positive x to the power of 3. Of course, minus x squared and minus 8x plus what? Plus 12, right? Yes, now I'm happy. Now a is positive. Therefore, you'll agree with me. Now, first, we need to have a factor here. Once you have a factor, the other one then will also be what? Ax squared plus bx plus c. Of course, boys and girls, now let us now try to see what will be the factor. What will be that number that when we substitute it here will give us a 0. Of course, we have x to the power of 3 minus alpha x squared and then minus 8x as well as positive 12. Then, of course, now I can say I want to start from where? I want to start from minus 5 will be fine, and also end at 5. That is your choice. That is the interval that you want to find those values. And now the steps 1, 1. Of course, now, boys and girls, we have the table here. From these tables, these are the x values, and this side we have the y values. Now, what is important is I must find 0 at f at x. If I find the 0 on this side, now I know that that value, when I substitute it in the equation, it gives me what? It gives me a 0. Minus 5 is minus 38 is not 0. Minus 4 is minus 36 is not 0. Minus 3 there. Minus 3, it gives me what? It gives me a 0. Very important. Now, it's not only minus 3, I believe. Minus 2 is 15. Minus 1 is 18. 0 is 12. And 1 is 4. And then 2 as well here is 0. Therefore, I know two values that when I substitute in this here, they will give me what? They will give me a 0. Now, what is the meaning of this one? It means x is equals to minus 3 here. Of course, we take this on the other side. X plus 3 now is our, we see now x plus 3 is our factor. Therefore, we can put x plus 3 here, or 1, because also when we substituted 2 here, then 2 we have y as a 0. One can also see now x minus 2 is a factor. Boys and girls, you must be very careful on this. Sometimes you'll be given to say, show that x plus 3 is a factor of f. It's very important, therefore, to show that x plus 3 is a factor of f, you just take minus 3, then you substitute it where? In the original equation. Therefore, if y is 0, then it means x plus 3 is a factor. Boys and girls, we have the first part here. Now we are looking for this one. We agree in this side we must have ax squared plus bx plus c. Yes, we must have ax squared plus bx plus c. Of course, boys and girls, there are many ways to solve this problem on this side. Others, of course, they are comfortable using long division method. There are many of them. Right, of course, let us see how can we find this one here. Of course, boys and girls, here I will put my factor here, minus 3. And now we take the coefficient 1 and minus 1 as well, minus 8 and positive 12. Right, boys and girls, 0 here. Why 0? Because you know that when you take minus 3, substitute it in there, we are going to get what? We are going to get y as 0. Right, 1 plus 0 is 1. Now we take minus 3 times 1 there. It is minus 3. Then minus 1 minus 3 is a minus 4. Negative 3 times negative 4. Of course, that will be what? That will be a positive 12. Then minus 8 plus 12. I also believe that that will be a positive 4. And you take minus 3 times 4. Then, boys and girls, the answer there will be minus 12. Can you see when I take a 12 minus 12 is 0? Yes, always when we get 0 here, it means now your calculations are 100% correct. Therefore, now I can say A is equals to 1, B is equals to minus 4, and therefore C is 4. Right, from here, here now I go straight here to say we have 0 is equals to x plus 3, and also these brackets here will be what? Will be x squared, because the value of a is 1. The value of b there is a minus 4x, and the value of c there is a positive 4. Right, now I have the 2 now. I have x plus 3 as well as x squared minus 4x plus 4. Of course, boys and girls, from here, I can now say, therefore, x is equals to minus 3, or then you factorize this one here. Factors here are what? X plus 2, no, x minus 2, as well as x minus 2 is equals to 0. Therefore, x is equals to what? Therefore, x is equals to positive 2. Right, boys and girls, these are the x-intercept of the graph of f. Remember, first, you equate f at x, y, h at x to 0. Then you look for common factor. If there's no common factor, you try to group the terms. If it doesn't work, now you must use the factor theorem. Right, boys and girls, let me say now, one now have decided to not to divide every term here by the negative. You leave the coefficient as a negative 1. Of course, it's very important, it's still the same. Right, what you must do there is that to say, of course, you have 0. You have 0 is equals to what? Minus x to the power of 3 plus x squared plus 8x minus 12. Now, you have 0 is equals to minus x to the power of 3 plus x squared plus 8x minus 12. Right? It means from here, when you find your factor, you're still going to use the same one, but also x plus 3 will still be a factor, I believe. X plus 3 will still be a factor. And then from here now, we are going to have this one here, right? Right. When I solve this one here, it means the coefficient now will be minus 1, will be positive 1, will be positive 8, as well as minus 12. Of course, the answer that I will get there will be minus x squared, will also be what? Will also be plus 4x, and this one will be minus 4. Right, boys and girls, what I want you to get right here is, of course, you can now say, therefore, x is equals to what? X is equals to minus 3. Or, sometimes, like we said, it's not easy to factorize, a quadratic equation if the coefficient of a is 1. Therefore, you can now say this is a minus x squared plus 4x minus 4 is equals to 0. Then now you can divide both sides by the negative to make it x squared minus 4x plus 4 is equals to 0. Right, now once we have it like this one, I believe now it will be easier for you to do what? It will be easier for me to factorize it. Right, boys and girls, I believe that you have this one right. Please, it's very important to make sure that you know how to determine the x-intercept of the graph. Right, now boys and girls, let us pass to the first question now, 11.1, where we had to calculate the x-intercept of the graph of f. The second question here, 11.2, now says you must calculate now the coordinates of the turning points of the graph of f. Right, what is important here is, what is it that we need for us to determine the turning points of the graph of f? Yes, so I can see now one is saying now we need to find the derivative. Of course, you are right. Once you have the derivative, now you let the derivative to be 0. Thereafter, you do what? You solve for x. Right. Once you have the x value, you take those x values, then you substitute them where? In the original equations. It's very, very important. Right. Boys and girls, also I think in 4 minutes time, then we're going to discuss this one. Make sure that you have the coordinates of the turning points. Right, thank you, boys and girls. Right, the question here says calculate the coordinates of the turning points of the graph of f. Right, yes. Now, what is it that you must do here? Like we indicated at the beginning, to say we need to take f at x. Now we find f prime of x. Right, now what is f at x? F at x there, we agree with me that that is a minus x to the power of 3 plus x squared plus 8x minus 12. Now we find the derivative of f. Then the derivative of f will then be what? Minus 3x squared as well as what? Plus 2x plus what? Plus 8. Of course, the derivative of minus 12 there, the derivative of minus 12 is, it's 0. Right, the second step, boys and girls, is that you must let the derivative to be 0. You must let f prime of x to be what? Let f prime of x to be 0. Then immediately after this one, now we have 0 is equals to minus 3x squared plus 2x plus what? Plus 8. Then from here now we solve for x. Of course, first of all, I will decide to divide everything here by the negative. We will get 0 is equals to a positive 3x squared minus 2x minus 8. Then from here now we factorize this equation. The factors are 3x multiplied by x would give us 3x squared. And now the factors of 8 is 2 times 4 or 1 times 8, right? But I believe that if I take 3 multiplied by 2, the answer will be 6. Then 6 minus 4, then the answer there will be 2. This is minus, and this one will be positive on this side. 3x plus 4, x minus 2. Our factors of 3x squared minus 2x minus 8. Now, therefore, now we can now say what? We can now say x is equals to minus 4 over 3, or also x is equals to positive 2. Boys and girls, now we have the x coordinate of the turning point. X is equals to minus 4 over 3, or x is equals to 2. Right, of course, you know how to determine the x coordinate. You find the derivative, then you let the derivative to be 0. Thereafter, you solve for x, right? Now we have the x coordinate of the turning point, right? What is it that you're going to do now to determine the y coordinate? Of course, we take the x coordinate minus 4 over 3, then you substitute it where? In the original equation where you have minus, then x is a minus 4 over 3 to the exponent of 3, plus, then also we have minus 4 over 3 exponent squared, plus 8 multiplied by what? Minus 4 over 3, then minus 12. Right now, what is it that you're going to have on this one? Of course, that is minus 4 over 3, then all to the power of 3, then plus minus 4 over 3, then squared, and then plus 8, then brackets there, minus 4 over 3, then minus 12. Then we have minus 500 divided by 27, which is, when you change it to the decimal, will be minus 18,5. Right, now we know that when x is minus 4 divided by 3 there, minus 4 over 3, then the y coordinate then will be what? Will be minus 500 over 27. Right, now we have the first one. Now the second one, you also do the same. You take 2, then you substitute it in the original equation. That will be minus, then 2 all to the power of 3, then plus 2 all squared plus 8 times 2 minus 12. Then the answer there is what? The answer there is 0. Of course, you can just work it out. It's 0. Why do I know that it's 0? Because this 2 is also the x-intercept. You remember here, the 2 is also the x-intercept. It means when you substitute 2 there, we are going to get what? We are going to get 0. Boys and girls, now we have the coordinates of the turning points. On this one here, we have what? We have a negative 1,3 as well as negative 18,5. And also the second one here, we have what? We have 2 as well as 0. Of course, you can look at this one now. Which one now? Because the graph of f now is decreasing. Why am I saying it's decreasing? The value of what? The value of a is less than 0. It means the graph decrease first. We are going to have the minimum turning points and increase after. Then immediately after that one, now we are going to have a maximum turning points. Right, boys and girls, from this one I can tell you now, this one will be the minimum turning points. This one will be the maximum turning points. Of course, let us see if this one is true now. 11.3 now they are saying now we must sketch the graph of f. We showing clearly all the intercept with the axis and the turning points of f. It's very, very important, right? Boys and girls, now I believe now we are left now with plus or minus few minutes. Of course, now can you just make a sketch of this graph of f? Then we can now see, compare yours as well as mine to see if you did it correctly. Right, thank you very much, boys and girls. Now, let us try to sketch the graph of f. Now, what information do we need to sketch the graph of f? Of course, we need the x and the y intercept. No, we need the x and the y intercept. Of course, the question here, we did not have the question that asks us to determine the y-intercept of the graph. It means looking at the graph, we know that when we determine the y-intercept, x must be 0, right? Then y here will be what? Y negative 12. There is a negative 12. That is y is negative 12. What is x? Of course, x is minus 3. Here is minus 3. And then y is what? Also the other x here is a positive. X is positive 2. Now we have x as well as the y-intercept. Of course, now immediately after x and the y-intercept, now we must look for the turning points. You remember now the values of the coordinates of the turning points here. We have minus 1,3 as well as minus 18,5, right? Minus 1,3, minus 1,3. Here is 1,3. Of course, with minus 18,5, that is 18,5. 18,5 minus 1, minus 1, minus 1, minus 1. This is positive. Minus 1,3 is on this side. Sorry for that. And thereafter, now we have minus 18. Then it means now our graph then will be on this side. That is the turning point. Of course, most of the time I encourage learners to indicate, immediately now shows that this one here, you must indicate that this is a turning point. Of course, it must be concave, concave up. Right, now immediately after this one, now we have the second turning point there. What is the second turning point? X is 0, y, x is 2, y is 0. Then this one as well, it is of course the turning point. You can see now this one now will be the maximum turning point. Thereafter now, boys and girls, you now just to join this. You don't have to use the ruler to join this one, boys and girls. Yes, you're not supposed to use the ruler. Then we have the graph of f. There we are. Then, of course, you remember because 8 was less than 0, the function decreased first. We have the minimum turning points here, increase and decrease. Now, immediately when it changed from increase to decrease, then we have the maximum. Of course, they said that we must indicate the coordinates of the turning points, this minus 1,3 as well as minus 18,5. And this one here is 2 as well as 0. Y-intercept there we can see is a minus 12 as well as the x-intercept is minus 3 as well as 2. Right, boys and girls, this is very important, especially when we are determining the equation of this function here. Look at this one here. If you find that the x-intercept is also the turning point of the graph, you will see that that point it repeats itself, right? If the x-intercept is also the turning points of the graph, then the point also repeats itself. It means it was x minus 2 multiplied by x minus 2. I believe, boys and girls, your sketch or your graph is as smooth as mine. Please make sure that you don't use your ruler to draw the graph. Okay, right. We also indicated that we have 11.4 that says that write down the x coordinate of the point of inflection. Right, boys and girls, what is it that you must do here? What is it that you must do here? Of course, you remember now, our first derivative was we need to find the second derivative. Then it means we need first derivative, which was minus 3x squared plus 2x minus 8 plus 8. This was our first derivative. Now let us find the second derivative. Of course, first f second prime of x is equals to, that is a minus 6x plus what? Minus 6x plus 2. Because just take 2 multiplied by minus 3 is a minus 6. Then the derivative of 2x is a positive 2. Then you let it to be 0. Then 0 is equals to minus 6x plus 2. Then take 6 on the other side. Positive 6x is equals to what? Is equals to 2. Then I divide by 6 on both sides. Therefore, x is equals to 1 divided by 3. Please, boys and girls, look at the question. Here they said write down the x coordinate of the point of inflection of f. It means in this case you are only looking for x, right? But sometimes they also say write down the coordinate of the point of inflection. Then it means in that case you must have x as well as what? X as well as y. Boys and girls, of course, I said one option is you can find the second derivative. You let the second derivative to be 0. And thereafter, what is it that you must do then? Then you solve for x. And then the other one I said, you remember, we have what? We have the x value at the turning point, right? The x value at the turning point. The first one is a minus 4 over 3. And the other one was x is equals to 2. Right, this is our x value, the turning points. I said you can also use the 2 to say x is equals to, you add the 2, minus 4 over 3 plus 2, then divided by 2. Right, let us see what is it that we'll get from this one here. Then, of course, we have minus 4 over 3, then plus 2 here, then we divide it by 2. Then we can see we still have what? We still have x as a 1 over 3. If you know what is the x value of the turning points, you can just add the 2 and then you divide it by 2. Then, of course, the other one is where you can also use x is equals to what? Minus b over 2a. From what? Your b then will be the 2. This 2 here, it means you have minus 2 here. Then, of course, divided by 2 multiplied by what? Yeah, a there, it's a minus 3. Then, of course, it's minus 2 divided by minus 6, which, of course, is still the same as 1 over 3. These are the options that you can use, especially when you're determining the x coordinate of the point of inflection. Of course, if the question says determine the coordinates of the point of inflections, now it means you must take now your x, then you substitute it where? You substitute x now in the original equations, of course, to find the corresponding y coordinate. Right, boys and girls, the last question here says, write down the coordinate of the turning points of h at x is equals to f at x minus 3. Write down the coordinates of the turning points of h. Now it means h now it's our new functions now, where h at x is equals to f at x minus 3. Of course, you'll agree with me that this one is a translation, it's a vertical movement. It means our graph now will shift what? Will shift 3 units, downwards. And the only thing that will be affected there will be the y coordinate of the turning point. It means what you're going to do there, just take minus 1, 3. Just take minus 1,3 and minus 18,5. Then we minus 3. And the other one, we also do the same. We say that is 2, then minus 3. Of course, this one is a 2 as well as minus 3 there. It's a 2 and minus 3. And this one is a minus 1,3. Of course, minus 1,3. Now you take 18, minus 18,5, minus 3. Of course, your answer then will be what? Will be minus 21,5. Remember now your graph will move vertically 3 units downwards. Boys and girls, of course, I believed that we've really learned a lot from this exercise, which is very important. I believed that if you can know how to sketch the graph, is very important. Therefore, finding the equation and interpreting the graph then will be what we have done when you sketch the graph. Right, boys and girls, I believe that if you have questions, if you need clarity on some of this one here, of course, you are welcome to ask questions so that at least you understand, you are well prepared before you can go and do what? Before you can go and write the paper on Friday. Right, now we go now to question 8 November 2011. We go now to question 8 November 2011. Of course, we are going to answer question 9. Now you can see now, it means now sketching the graph, now at least we are happy with that. Now it means now, let us see now what is it that we need now when we determine the equation. When we determine the equation of f, when we determine the equation of g. Boys and girls, before we take the break, let me now summarize what we did at the beginning of these sessions. Of course, boys and girls, we looked at the graph of cubic functions. We said that when you sketch these cubic functions, what is it that you need? We said you need to find the x and the y intercept. We said for x intercept, you let y to be 0, and also for what? And also for y intercept, you let x to be 0. And thereafter, immediately after that, what is it that you're going to do? Then immediately after that one, of course, you need to remember the shape of the graph. The shape of the graph here, if a is greater than 0, your function will increase. If a is less than 0, the function will start decreasing. Then if decrease, the first turning point will be the minimum. If increase, the first turning point will be the maximum. Of course, now we have said now x and the y intercept. Of course, for x intercept, of course, you need to find the factors. First, to look for common factor, you group the terms or use the factor theorem. Turning points, you find the derivative. then you let the derivative to be 0. Of course, boys and girls, thereafter you solve for x. Once you have the x value, you just take the x value, then substitute them where? In the original to get the y coordinate of the turning points. Thereafter, now you can now be able to draw what? To draw a smooth curve. Stating the nature of the turning points, of course, it will depend on the value of a. Of course, the lowest value of x, if a is positive, will be the maximum, and the highest one will be the minimum. And also, when a is less than 0, the lowest x value will be the minimum, will give us the minimum turning points, and the highest one will give us the maximum turning points. And the last one that we have looked at is how to find the point of inflection. Of course, we said we need the second derivative, and we must let it to be 0. Solve for x right now. That's what you must do. And these are another options that we can do. Remember, the question can say to you, determine the x coordinate or determine the coordinate of the point of inflection. Boys and girls, try to go through this one again. Of course, I believe that you're going to have just a 10 minutes break. Now, immediately after this one now, we'll be now looking at the equations of the cubic functions. Right, welcome back, boys and girls, after the short break that we had. Now, remember now, this session I said now we are going to try to see if is it possible for us now to determine now the equation of f, the equation of the cubic function name. Right, of course, you have seen what is it that we need when we do what? When we sketch the graph of f. Right, now let us look at this. What is it that we need, especially when we determine the equation. Of course, now I said here we have question 9. Here we have the function. The function f at x is equals to minus 2x to the power of 3 plus ax squared plus bx plus c sketched below. The turning points of the graph of f are 2 and minus 9, as well as the coordinates of the s there is 5 as well as 18. Right, basically from this function you can see that the information that is given here is only what? It's only the turning points. Right, 9.1 says show that a is equals to 21, b is equals to minus 60, and c is equals to 43. Show that a is 21, b is equals to minus 60, and then c is equals to 43. Right, boys and girls, now let us see 9.1. What is it that we need? Of course, we know that for us to have the turning points, we know what is that we must do now. First, to have 2 as well as 5, then we must find the derivative. Is that correct? We find the derivative, we let the derivative to be 0. Of course, now we solve for x. That is where we end up having the 2 as well as 5. Now, what do we do now to get minus 9 as well as 18? Of course, you take 2, you substitute it there to get minus 9. And also you take 5 to substitute it in the original equation to get what? To get 18. Boys and girls, it means that is the information that we need for us now to solve this problem here. Right, now we have f at x is equals to minus 2x to the power of 3 plus ax squared plus bx plus c. Right, now we said for turning points we need the derivative. It means now we must have f prime of x is equals to minus 6x squared, that is the derivative of minus 2x to the power of 3, of course, plus what? Plus 2ax, then plus b. Right? Of course, that is the derivative of f. Right, basically, now what do we know is at the turning points, we let the gradient to be 0. Is that correct? And the other thing that you must also understand is if you take the x value, that you have obtained from that derivative when you solve for x, you substitute them in the derivative, you're going to get your y as what? You're going to get your y as 0. Then it means now, when we substitute 2 here, then our y will then be what? Our derivative will then be 0. That is why now we are going to have minus 6 into 2 all squared plus 2a times 2, then plus b. Right, of course, boys and girls, now when you multiply the 2, we have 4 multiplied by minus 6. Then the answer there is what? The answer is minus 24 plus 4a plus b is equals to 0. Right, immediately when I see that I have 2 unknown, I can see down this one I need to have 2 equations so that I can now do what? I can now be able to solve them simultaneously. Of course, from this one then, that is 24. 24 minus 4a is equals to what? 24 minus 4a is equals to b. I can now say this one will be there. This one will be the first equation. Right, of course, boys and girls, from here now, we do the same again. We know that if we take 5, then substitute it in the derivative, we will get y as what? We'll get y as 0. Therefore, we have 0 there is equals to minus 6 times what? Minus 6 times 5. All squared plus 2a multiplied by 5, then plus b. Then, of course, from here now we simplify to say that is 25 multiplied by minus 6. Then the answer there is a minus 150 plus 10a plus b, right? That is 150 plus 10a plus b. Then I can name this one to be the second equation, or you can decide to take the 150 and 10 on the other side so that you have b as a subject of the formula. That will be your option. Of course, now the next step now I can see now, what do I do now? I substitute b now with what? I substitute b now with 24 minus 4a. Right, of course, now we'll therefore have what? 0. I then have 0 is equals to minus 150, then plus 10a plus what is b now? We substitute b now with 24 minus 4a. Right, from here now we solve. I take 150 on the other side, it is positive 150 plus 10a plus 24, we multiply by the positive and minus 4a. Of course, when I take 24 on the other side, we are going to have what? 150 minus 24 is equals to, of course, 10a minus 4a. What is 10a minus 4a? Of course, that will be what? That will be 6a. And now we take 150 minus 24. 150 minus 24 is 120, 126. Then you divide by 6, Therefore, a then is equals to what? A is equals to 20, a is equals to 21. Then we can see now we have the value of 21. We can just check here as well. They said now we must show that a is equals to 21. Then boys and girls, we are happy now we have the value of a as 21. Now how do we get the value of b? Of course, we can just substitute a in one of the two equations. Let me take the first equation to say we know that b is equals to 24 minus 4 multiplied by 21, right? Of course, we are going to have what? We are going to have 24 minus 4 times 21. 4 times 21 will be 84. Will be 84. Of course, now from this one you can say 84 minus 24. Then the answer there will be minus 60. When you take 24, then you subtract 84. Then your answer is minus 60. And boys and girls, if we check this one as well, we can see now we have the value of b there as a what? As a minus 60. Now we are left now with c. The question is now, what is it that you're going to do now to substitute to get the value of c? What is it that you're going to do? Yes, we can just take one of the two to say we know that f is equals to what? We know that f at x is equals to minus 2x to the power of 3 plus what is the value of a? A is 21, x squared, and then b is a minus 60 x, and then plus what? Plus c. It means the only thing that we need down is to determine the value of c. Right, boys and girls, what we can do now, we can just take one of the point here. It's either you take point T or you take point S, where now you say, I know that when I determine the y value at the turning points, I substitute x in the original. It means when you substitute 2 in the original, our y must be what? Our y must be minus 9. It means now we do what? We substitute the point T where x is 2 and then y is minus 9. Right, let us see what is it that you're going to get there. Then we have minus 9 is equals to minus 2 into 2 to the power of 3 there, plus 21, 2 squared, minus 60 times 2, then plus c. Let us now simplify. That is 8 times minus 2. That will be minus 16 here, plus then 4 times 21. That will be 84. Then minus 120 plus c is equals to minus 9. Then of course now if I move everything on the other side, this one will be minus 6 plus 84 plus minus 120. Minus 120, it is equals to what? It is of course minus 40, minus 42. That is minus 6 plus 84. Of course, plus 84 minus 120, then it's minus 42. And now we take it on the other side to have what? Take it on the other side now to have positive what? Positive 42 here. Minus 9 is equals to? No, not 6. Let me see. Sorry for this one here. That is, should be 16, because that is 8 times 2. Yeah, that should be 16 here. That is negative 16, because 8 to the power of 3. 8 to the power of 3 is what? It's 8. 8 multiplied by minus 2, then it will be minus 16. Right. Now, let me see now. Minus 16 plus 84 minus 120. Then the answer there, it is 52, not 42. Then we have 52 minus 9 is equals to C. Then 52 minus 9, of course, then the answer there is 43. Therefore, the value of C now, you can see it is 40. It is 43. Boys and girls, what is it that we have done here? I think it's very important. I've seen that we are given the coordinates of the turning points. It means the first thing that we did here is to find the derivative. Why? Because we know for us to have the turning points, we need the derivative. Now, it means then immediately once you have the derivative, we substitute the value of x at the derivative, so that we know that when we substitute the value of x, y will be 0. And now we simplify. We had the first equation, which is 24 minus 4a is equals to b. Then another one now is we substituted the second value of x there as well. See now to have what? To have minus 150 plus 10a plus b. Of course, now we can see now we have two unknown. We can make now b the subject of the formula, then we substitute it in. Now, I know the question will be, what if I take the x and then thereafter I substitute minus 9 as well as 2? Of course, if you do this one in the next step, you are going to have 3 unknown. You are going to have 3 unknown. Your unknown will be a as well as b as well as c. That is why it will be easier for you or advisable to you to say, if I have 2 turning points and the value of x as well as y, first, what is it that you must do there? You just substitute the x, and later on now you can substitute the x as well as y. Okay, thank you, boys and girls. I think now you have this right. Of course, 9.2 was to determine the equation of the tangent to the graph of f at x is equals to 1. Of course, you looked at this one yesterday. X is 1. Now you need to find the y value here. You need to find the y value here. How do you determine the y value? You just take 1 and then substitute it where? Substitute it in the original equation where a is 21, b is minus 60, and then c is 43. You have the corresponding y value. And also you need the gradient of that point. It means you must also take 1 now, substitute it in there. In the derivative, where now a is what? Where now a is a minus 60, and now b is, no, where a is 21, and then b is minus 60. Now the value that we'll get there will be the gradient. Of course, boys and girls, you looked at the equation of the tangent yesterday, and later on this morning we looked at the x value at which the graph has a point of inflection. We said now you need to determine what? You need to determine the second derivative, and thereafter you let it to be 0, and you solve for x. Right, boys and girls, what I want us to look at today most is to say, how do we determine the equation? It is very important. How do we determine the equation? The first question, we had 2 turning points, right? The first question, we had 2 turning points. Now, what about the second one now? Look at this one, 2013 paper 1, question 9. The function here defined by f at x is equals to x to the power of 3 plus ax squared plus bx minus 2. This function that you see there is defined by f at x. Defined by f at x is equals to x to the power of 3 plus ax squared plus bx minus 2, right, is sketched below. P and R are turning points of F, but we only have P, which is X coordinate is 1 and Y coordinate is also 1. We don't know what are the coordinates of R. Right now, 9.1 now says, show that A is equals to 1 and B is equals to minus 1. Show that A is equals to 1 and B is minus 1. Of course, boys and girls, now, P is a turning point. This is minus 1 here, and this one is a minus 1 as well. P is a turning point. At the turning point, we have the X as well as Y. Right? It means what you are going to do, first one is that we know that when we substitute 1 at the original equation, we are going to get the corresponding Y value, which is what? Which is minus 1. You substitute minus 1 in the original equation, you get the corresponding Y value, which is negative 1. Right, that's what you're going to do. If we substitute now negative 1 to the power of 3 plus A times negative 1 squared plus B multiplied by negative 1 minus 2, then the answer that you are going to get there, it will be minus 1. Then from here now we solve to say minus 1 to the exponent of 3 is a minus 1, then plus minus 1 squared, it's a minus 1 times A is A, then minus B minus 2. Then we simplify this one to say this one now will be what? This one now will be, I take B on the other side is a positive B, then we have A, 1 on the other side, minus 1 plus 1 is 0, then minus 2. Right? Yes, boys and girls, B is negative, it is positive when I take it to the other side. Now this one, minus 1 minus 2 is a minus 3. Minus 3 plus 1, it is minus 2. Right, A is still positive. Of course, you can see I have two unknown. Of course, I will have to call it to the equation number 1. Right, now we have used it. The first thing that you know to say, if we have the X value at the turning points, to find the corresponding Y value, you substitute the X in the original to get the Y value. Right, now the second one that we know is, of course, if we have the derivative f prime of x, which is equals to what? 3x squared plus 2ax plus bx, right? If we take this one, we substitute what? We substitute minus 1 squared plus 2a times minus 1 plus b. If we substitute minus 1 in the derivative, then our y here, our derivative will be what? Our derivative will be 0. And then, of course, from here now, we are going to have negative 1 squared is 1. 1 times 3 is 3. Then minus 2a plus b. Of course, I can take 3 on the other side. That will be 3 is equals to minus 2a plus b. Then I can now name this one to say this is my second equation. Right? Now, the next thing now we'll say now, let us now substitute equation 1 into equation 2. Why am I saying this one? Because now we know what is b. Our b here is a minus 2. Right, now we go to say 3 is equals to minus 2a plus what is b? Our b is a minus 2. Therefore, when you simplify this one is 2a plus a minus 2. Right? Of course, boys and girls, now this one here minus 2a plus a, then we get what? Negative. Yes, we get negative what? We get negative a. Right? Yes, now immediately from this one, now we can now move to next to say, let us take this one on the other side. Now we have 3 plus what? We have 3 plus 2. Then the answer there, now it should be negative 3 here. Negative 3, of course. Negative 3, then the answer then will be negative 1. Then negative a here. Then now divide by negative 1, divide by negative 1. Then a is equals to 1. Right, boys and girls, now let us go back to this one. Remember the first part we said you substitute x to get y as your corresponding y value at the turning points. That is why we have b is equals to a minus 2. Right, now the second one, we find the derivative f prime of x. Then from that one, you substitute the x. When you substitute the x value, the x coordinate of the turning point in the derivative, your y will be what? Your y will be 0. That is 0. Now I have positive 3 here. When I move it to the other side, it becomes negative 3, right? Therefore, we have negative 3 is equals to 2a plus b. That will be the second equation. Therefore, now I can now say we substitute equation 1 into equation 2. It means now in this equation, wherever I see b, then I replace it with a minus 2. Then here's a minus 3 is equals to minus 2a plus, now our b now is a minus 2. Then we simplify, then we still have negative 3 here. Then of course now when I move 2 on the other side, it is minus 3 plus 2. Then minus 2a plus a, of course it's a minus a. Then I divide both sides by the negative. That is why now a is a positive 1. Right? Boys and girls, of course a here as well. They said that we must show that a is 1. Now, what is remaining now is to find the value of what? The value of b. Right, now, what is it that we are going to do here? We just substitute a in one of the two equations. Therefore, now I can say b is equals to 1 minus 2. Then the answer there will be a negative 1. Right, boys and girls, now, what is the difference between the first question that we did as well as this one here? The first question that we did, we had 2 turning points. That is why we have used 2x value at the turning point to say we substitute 2 in the derivative, we also substitute 5 in the derivative. Now to find the value of c, now we said let us take 1 point at the turning points, because we know that when we substitute x, you get the corresponding y value. Right, now, in this case, we have only one turning point, which is p here, minus 1 as well as negative 1. Right, what we did here, because it's only 1, we know for us to have this point here, first, if you know what is the x-coordinate of the turning point, you substitute it in the original to get the y-coordinate of the turning point. So that's what we did. And also now to have minus 1, we need to have the derivative. And thereafter, now when I substitute minus 1 in the derivative, then y will be 0. Then I had the equation 2. Then you solve the 2. Boys and girls, please make sure that you practice the 2, where you have the 2 turning points, and the other one where you have what? The other one where you have one turning points. Right. Boys and girls, now, of course, now I think you are comfortable now using the turning points, the derivative, and then to get the y value. I think you are happy with that one. Right, now, I think the last one that you're going to look at under this one where we find the equation is where now we are given now the x-coordinate, which is very important. Now, the x-intercept of the graph. Right, boys and girls, let me read the statement. The statement here says, the graph of f at x is equals to ax to the power of 3 plus bx squared plus cx plus d. And we have g at x is equals to 6x minus 6 as sketched below. Immediately when I look at this one of the questions will then be, I must find the value of b, the value of a, b, c as well as d. And now what is g? G is a straight line as well. Right, now, boys and girls, now we have a, the coordinates of a, there is a minus 1 and 0. Here is a minus 1 and 0. And the coordinates of c, 3 as well as 0. These are the x-intercept of f. I'm happy now I have the x-intercept of f. Now, the graph of f has the turning point at a. What is this a? A is also the x-intercept. Now, I remember something that we've mentioned earlier on to say, if a point is the x-intercept and also a turning point of the graph, it means that point repeats itself, right? Okay, great. I'm happy that you still remember that one. And as well as the other turning points will be at B. Right, D is the y-intercept of f. Now, E and D are the points of the intersection of the graph of f as well as the graph of G. Right, boys and girls, now we need to identify the given information. Right, the first question here says what? Show that A is 2, B is minus 2, C is minus 10, and D is minus 6. Of course, now to get to this one here, right, let us look at what is it that is given here. We have the x-intercepts of f. Right, boys and girls, you remember from the quadratic as well. From the quadratic that if you are given the x-intercept, you can now say a into x minus x1 and then x minus x2, right? But this time now we are not in quadratic. Now quadratic we have 2 x-intercept, but cubic now we have how many? We have 3 now, x3, right? Now of course that is a. Now we substitute this one here, that is x minus 1. Right, we know that this one repeats itself. You can just put 2 here to say that is a into x minus minus 1 all squared, or you can write it the way you will understand it. It's very important. Now I can see now the 2 repeats itself. It is x plus 1 as well as x plus 1. Right, now this one here is x minus 3. 3 is positive, then it will be x minus 3. Of course, we still have x minus 3 as well on this side. Right, now from here, boys and girls, you can see now I'm happy now with everything. I'm happy. I know this is x plus 1, this is x plus 1, this is x minus 1. But now the problem now is the value of a. Now, the problem now is the value of a. Now, what is it that I'm going to do now to have the value of a? What is it that I'm going to do now? What is that I must do to find the value of a? Of course, I can see now you must say there is a point on the graph. You are right. There must be a point of the graph that we are going to substitute there. Substitute d, which is 0 and minus 6, to have the value of a. Right, now let us substitute our y here. It's a minus 6. Then a into x is 1, x is 0 plus 1, and 0 plus 1 as well, and the other one is 0 minus 3. Right, boys and girls, when I simplify this one, it's a positive 1 minus 3. Right, this one times 1 is 1, 1 times minus 3. Therefore, we are going to have minus 3a is equals to what? Is equals to a negative 6. Thereafter, from this one, now I divide by minus 3. I divide by minus 3. Therefore, a is equals to what? A is equals to 2. Then I'm happy now. I know what is the value of a. A is a 2. Therefore, we take a now. We substitute it back here to say we set f at x is equals to a is 2 into x plus 1 as well as x minus 3. Therefore, from here now we multiply to the brackets. Say this one, these two, I know they will give me what? X squared plus 2x plus 1. That is x squared plus 2x plus 1. Then I still have to multiply it by x minus 3. Boys and girls, you can start with the first two or the last two. Just multiply, then you multiply with the other one later on. Then later one, now we say 2 into x squared times x is x to the power of 3. X squared times minus 3 is a minus 3x squared. And now we are done with this one. 2x multiplied by x. That will be what? That will be plus 2x squared, and 2x multiplied by minus 3. That will be minus 6x. That will be minus 6x. 1 times x is a plus x. 1 times minus 3 is a minus 3. Of course, put this inside the bracket so that I still have to multiply them by what? By 2. Then let us simplify now. We have x to the power of 3. Like terms, minus 3x plus 2x, x squared. These are the like terms because x and x, same base and same exponent. Then you're going to have minus x squared here. And also same base, same exponent. Therefore, this one will be what? This one will be minus 5x. Of course, minus 3 here. Then I multiply by 2. That will be 2x to the power of 3 minus 2x squared minus 10x minus 6. Then immediately from here, I can now see to say, therefore, a is equals to 2, b is equals to minus 2, c is equals to minus 10, and d is equals to what? D is equals to negative 6. A is equals to 2, b minus 2, and c minus 10, and d is equals to negative 6. Of course, boys and girls, when you compare your answer with this one, now you can see that A is 2, B is minus 2, C is minus 10, and D is minus 6. Of course, right, I believe that what we have learned from these three examples that I did, boys and girls, the first one we had 2 turning points. Of course, you know what is it that you do there? You find the derivative, and then immediately after that derivative, you do the substitution. The second one, we had only 1 turning point. Of course, we did that one. We substituted 1 in the negative 1 into the original to get the corresponding y value, and you also used the derivative. Then we substituted that x into the derivative to get y to be 0. Right, this one also, it means now also you can be given the x-intercept now to do what? To determine the equation of the cubic functions. Boys and girls, what's important is you must remember that if this point here is the x-intercept as well as the turning point. It's very important to know that the point repeats itself, right? It's very important to remember that that point repeats itself. Okay, right. Now, boys and girls, quickly now, in less than 10 minutes, in less than 5 minutes, let us look at the last one, name. Remember now, these are maybe types of questions that we can expect in that paper, especially under the cubic functions, name. Right, I always say when we get to the quadratic under calculus, when you get to the quadratic, you must remember now, this is the derivative. When you get to the quadratic under cubic functions, now you must know that this is the derivative of what? This is the derivative of f. Quickly, when you look at this question 9 November 2010, they are saying now the graph of y is equals to g prime of x is equals to ax squared plus bx plus c. Then I can see now this one must be the derivative of what? It must be the derivative of g. And h at x, of course, is a straight line. The graph of y is equals to is derivative of the graph of a cubic function g. Now here it is now. They are saying now the graph of g prime of x is the derivative of what? Is the derivative of the cubic function g. A is the x-intercept of h. Where is a? There it is a. And now we have b is the turning point of g. There it is b. And also AB is parallel to the y-axis. Right. Boys and girls, look at the first question there. Write down the coordinates of E. Write down the coordinates of E. Of course, E, we cannot use G prime. Why? Because we don't know what is the equation of this one. But of course, you take H, because H at x there is equals to 2x minus 4. Then you let x to be 0 at this point here. Therefore, y is equals to 2 times 0 minus 4, then it means you are going to have minus 4. The coordinates of E there is what? The coordinates of E is 0 and minus 4. Right, boys and girls, I want us to go quickly now to 9.2. 9.2 says now determine the equation of the graph of G prime in the form y is equals to ax squared plus bx plus c. Right, now it means now this is the quadratic, boys and girls. You remember last time, you did the quadratic functions. Now, what is important is when you determine the equation of the quadratic functions, you need to check the following. The given information, if it is the x-intercept, then of course it will be x1 as well as x2. But if it's a turning points, it will be a into x minus p all squared plus q. But when I look at this information here, we are given the what? We are given the x-intercept. It means now I will say y is equals to a into x minus x1 and x minus x2, right? Now we substitute that one to say this will be x minus 2 and x minus 6, which is equals to now x plus 2 and x minus 6, right? We are happy now with the information that we have, but now the challenge is now the value of what? The value of a. What do you do? Remember, most of the time, if not always, the point must be given on that graph so that you cannot be able to determine the value of, a. Then it means now we substitute the point. What is the point that we're going to substitute there? It's a, which is 0 and minus 6. Now we have minus 6 is equals to a into 0 plus 2 and 0 minus 6. Of course, 2 times minus 6 there. The answer there will be what? Will be minus 12a. Then this one is a minus 6. Then I divide by minus 12, divide by minus 12. Then a is equals to 1 over 2. Right, boys and girls, now you have a. You just substitute this one to say y is equals to here 1 over 2 into x plus 2 as well as x minus 6. Then you multiply the brackets and you get x squared minus 4x minus 12, multiply by half, then you have half x squared minus 2x minus 6. Right, boys and girls, now this one will be the equation, that is g prime of x, which is the derivative of what? Which is the derivative of g. It's very important you can get something like this one in the paper. Right now, write down the x-coordinate of the turning point of g. Boys and girls, I will be happy to get this type of questions because I know that the x-coordinate of the turning point of g will be what? Will be the x-intercept of the graph of g prime. Then it means the answer for this one will be the x-coordinates of the turning points, that is x is equals to -2 and also x is equals to 6. Then the x-coordinates of the turning points will be the x-intercept of the graph of the derivative g prime. Right, the last one now, write down the x-coordinate of the point of inflection of the graph of g. Boys and girls, this one is very interesting. That is why earlier on I've mentioned now those options that we can use when you determine what? When you determine the x-coordinate of the point of inflection. Right, what is it that you can do here? Two options. You can use x is equals to minus b over 2a, or you can use x is equals to x1 plus x2 divided by 2. This one, you just take the x-intercept of the graph. You say this is -2 plus 6 divided by 2. Then the answer there will be what? The answer there, -2, that is 4 over 2, which is equals to 2. Exactly the same when you take what? When you take x is equals to minus b over 2a, or finding the derivative, because now you have what? Because now you have half x squared minus 2x minus 6. Okay, boys and girls, now in closing now we have 9.5 that says now explain why g has the local maximum at x is equals to -2. Remember now, the maximum, we said we will have the maximum value name if the graph increase first and decrease after, or we'll have the minimum when the x decrease and increase. Right, when you look at this one here, that is a point C where x is 2. Then f prime of x here, f prime of x is greater than 0. We agree on this one. It means that is g now. G prime of x is greater than 0. It means now g here, g at x here is increasing. Then it is increasing. G here, it is increasing. Right, now you can see now the second one here below the x-axis here, you can now say g prime of x, it is less than 0. Right, if it's less than 0, then our graph now is decreasing. Therefore g at x now is what? Is decreasing. Right, it is decreasing. Right, now let us look at the shape now. I said g prime of x is greater than 0, then it means g at x is increasing. It means we have something like this one here. G is increasing, therefore immediately now after -2 now, g now decreasing. Can you see now? If increase and decrease, then we see now we are going to have the local maximum at x is equals to -2, because at this point g prime of x is less than 0. It means g is decreasing. If it's decreasing, remember where x is less than 0 and increase. Now this one will give us the minimum. Boys and girls, make sure that you understand, you are able to interpret these graphs. It's very important. Now I know that of course there are a lot of marks under calculus functions as well as the rules and first principles. Right, make sure that you practice this one. I know you are going to make it at the end of this year, especially on Friday where you will be writing paper 1. Good luck, boys and girls. You are writing this afternoon. Make sure that you push harder to make sure that next year you smile. Thank you very much.